Hey everybody, this lesson is equivalent ratios and the multiplication table. So we're going to use our multiplication table to find equivalent ratios. And don't forget, all your lessons can be found at Mrmathblog.com. Okay, let's get started. There's our Common Core strand, and our question here is how can we use a multiplication table to find equivalent ratios? Okay, so here you guys, this table down here shows two rows. So the first row is for baskets, the second row is for apples right here. Okay, and so the multiplication table over here is highlighted with row 1 right here, and here's row 6 right here. Okay, so the ratios show each column of the table are equivalent to the original ratio. So here's the original ratio, 1:6. So here it is right here, 1:6 right here. So ratios that have the same comparison are called equivalent ratios. So here's 2 times this top number, 2 times 1. Here's 3 times 1. Here's 4 times 1. Here's 5 times 1. And since our ratio that we're focusing on here is 1:6 right here, here's 2 times 6, 3 times 6, 4 times 6, 5 times 6. And so 2 times 6 is 12. 3 times 6 is 18. There's 4 times 6, and there's 5 times 6. Okay, so our ratio is 1:6. Here's 2 times 1, so we did 2 times 2 to get 2/12. Those are equivalent ratios. Okay, so we multiplied the top number times 3. 3 times 1 is 3, and then the bottom number, 3 times 6, is 18. So 3/18 is the same ratio as 1:6. I'm at school, so it's right before school. People are coming in. You're going to hear some doors slamming and stuff. Anyway, so this is how we're going to use this multiplication table. We're going to use the rows right here to represent our ratio that we're focusing on, and then all of these numbers, this 3 over 18, this 4 over 24, this 5 over 30 are called equivalent ratios. They're equivalent ratios to 1/6 right there, okay? All right, so here we go. The ratio of pets to people in a certain neighborhood is 3:8, okay? So what this means is there's 3 pets for every 8 people in this neighborhood right here. So write two ratios that are equivalent to 3/8. Okay, so let's get started. We're going to use this multiplication table, and we're going to show the rows of the original ratio. Let's and by shading them. So let's shade the row 3 and the row 8. Okay, now this is how I remember between columns and rows, you guys. Rows go sideways and columns go up and down. Like in a coliseum, you need these columns that go up and down that hold up a coliseum. So coliseums go this way, rows go this way. All right, let's go back to that problem here. So all right, let's shade the row 3 for the numerator, and we'll shade the row 8 for the denominator right there, okay? All right, and that's going to be the rows 3 and 8. So here we go. Let's shade those right here, okay? So all of these are equivalent ratios. Here's 3 times 1. Here's 8 times 1, okay? Here's 3 times, let's go to 3 times 5. 3 times 5 is the same ratio if I do it over 8 times 5, which is 15. I'm sorry, 40, sorry. So 15 over 40 is the same ratio as 3 over 8. In fact, 3 times 7 is 21, so if we do 8 times 7 is 56, 21 over 56 is going to be the same ratio as 3 over 8. Okay, so now what we're going to do is circle some columns that show the original ratios. Okay, we can circle any two columns. I think I'm just going to circle the next two columns. So I'll circle this column right here, and then this column right here. So there's one group of 3 pets for every 8 people. All right, let's circle. There's the first one right there. Okay, and then, so there's the column that shows the original ratio, 3/8 right there. Okay, let's slide all that stuff up right there. And then here's step 3. Let's go ahead and circle 2 more columns that show equivalent ratios. Okay, I'm going to circle these 2. I could have circled these 2 if we wanted to, this column and this column right here. Okay, in fact, this column keeps going. We can go 3 times 10 is 30, and then 8 times 10 is 80. 30 over 80 has an equivalent ratio of 3 over 8. All right, so now that we circled those, you guys, so the column 2, here, this column 2 shows that there are 2 times 3, or 6 pets when there are 2 times 8, so the same column. So if we go down here, 2 times 8, or 16 people right there, okay? And similarly, the column for 3 shows 3 times 3 is 9, okay? And then 3 times 8 is going to be 24 right there. So 9 over 24 is going to be an equivalent ratio. So these equivalent ratios, 6 over 16 and 9 over 24, are going to be equivalent to the original ratio, 3 over 8. And that's how we use our multiplication tables. What we do is we get our original ratio, and then we shade that row right there, and then shade that row, and then we can pick any one out of this rows, or out of this column right here, as long as we pick it out of the same column in the other shaded row right there. Okay, so explain whether the multiplication table that we just used represents all the ratios that are equivalent to 3/8. Okay, well, no, we can keep going on infinitely over here. You know, this row we can do 10 and then 11, a column for 11. So 3 times 11 would be 33. 8 times 11 would be 88. So 33 over 88 would work. 30 over 80 would work. So the rows for 3 and 8 in the multiplication table can extend forever, endlessly. So we can write an unlimited amount of ratios that are going to be equivalent to 3/8 right there. All right. Here's another one here. So Jack made an Arnold Palmer by mixing 2 pints of iced tea with 5 pints of lemonade. So if you ever had Arnold Palmer, it's a mixture of iced tea and lemonade. It's pretty good. So to make more of this, Arnold Palmer, he needs to mix the iced tea and lemonade in the same ratio. So we're going to write 3 equivalent ratios to 2/5. Okay, so here's our multiplication table we're going to use. And notice we shaded the row 2 and the row 5. And so all these numbers, this over this, this over this, 6 over 15, all of those, as long as we pick out of this row and this row, and then we pick them out of the same column, we're going to have the same ratio. Okay, so we're going to use the rows from the multiplication table to help complete the table of equivalent ratios. Okay, so here, this is going to be 2 times 2, this is going to be 3 times 2, so this one's going to be 4 times 2, which gives us that 8 right there. And similarly, our original ratio is 2/5, so here's 1 times 5, here's 2 times 5 we're going to put in here. This is going to be 3 times 5, and this is going to be 4 times 5, okay? All right, let's put these in. So 2 times 2 is going to be 4, and then 3 times 2 is going to be 6 right there, okay? And then right here, 2 times 5 is 10, and then 4 times 5 for there is going to be 20 right there, okay? And can you see this 4/10 right here? 4/10, as long as they're out of the same column. Here's 6/15, here's 8/20, and if we wanted to, we can do 10/25. Okay, so we shaded the row for the 2, we shaded the row for the 5 to represent our ratio of 2/5, and then we just pick the numbers out of the same column, and that'll give us equivalent ratios. Okay, so 2/5, and let's go ahead and put this ratio in. 4/10, 6/15, and 8/20. They're going to be all equivalent ratios right there. Okay, easy, huh? All right, so here's another way, you guys. We can multiply or divide by a form of 1. So let's go ahead and write 2 equivalent ratios for 6/8. Okay, so here we're going to multiply by 1, and here we're going to divide by 1. But our 1 is going to be the same number on top and on bottom, because remember, any number over itself equals 1 right here. So we can multiply 6 times any number as long as we multiply 8 times the same number. I think I chose 3 right there, so I put 3 on both of them. You just got to make sure you do the same number on top and on bottom. Okay, 6 times 3 is 18. 8 times 3 is 24 right there. Okay, so 18 over 24 is going to have the same ratio as 6 over 8. And we can do the same thing as long as we can divide both the numbers by the same number. Is there a number we can divide 6 and 8? You know, our hint is that they're even numbers. What number goes into even numbers? 2 does. So let's divide it by 2 here and divide it by 2. We just got to divide by the same number to make it a form of 1. So when we divide the top and bottom by 2, 6 divided by 2 is 3. 8 divided by 2 is 4. So 3 over 4, 3/4 is the same as 6/8 right there. So is 18 over 20. Okay, we can multiply this by 4. 6 times 4 is 24. 8 times 4 is 32. 24 over 32 22 would be the same ratio as 6 over 8. All right, so let's answer the question. So 6/8 and 18 over 24 and 3 over 4 are equivalent ratios right there, okay? All right, so explain how ratios are similar to fractions and explain how they're different. Okay, well, ratios and fractions make a comparison by a division problem. So if you saw a fraction like 1/2, that's the same as 1 divided by 2, which is 0.5. 1 divided by 2 is 0.5. Anyways, both can be written using a numerator and denominator. And then ratios can also be written with the word 2 in it. Remember that from the last lesson? Or by using a colon in between the two numbers. All right, there's good old Arnold Palmer. Take care, you guys.